Okay, we're looking at proportional reasoning, and the method we're going to use is by graphing. Overall expectation is to solve problems involving proportional reasoning, and the specific expectation is to solve problems involving ratio rates and directly proportional relationships in various contexts using dynamic software to construct and measure. So we're going to use some software to help us with the graphing of this question. Okay, so here's our question. We'll read through it once, and then the second time we'll read it through and highlight what we think is important. Adriana works at a veterinarian's office. She needs to give a dose of medicine to a 22-kilogram dog. The recommended dosage for a dog that weighs 12 kilograms is 30 milliliters. Determine the dosage Adriana should give to the 22-kilogram dog if the rate remains the same. And then finally show your work. Okay, so let's highlight. She works at a vet's office. That's great. Not as important to us. She needs to give a dose of medicine to a 22-kilo dog. That's important. We now know the weight of the dog. The recommended dosage for a dog that weighs 12 is 30 milliliters. So 12-kilo dog is a 30 milliliter dosage. Determine the dosage Adriana should give to the 22-kilogram dog. We already know that. If the rate remains the same, okay, so we know the rate is the same for this. And we need to determine the dosage. Determine the dosage. That's our important parts here. Okay, so let's kind of set up a chart here. We know we have kilograms, okay, and we also have milliliters, okay, and the only information we have this far is that a 12-kilogram dog would get a dosage of 30 milliliters, so that's good for us to know. We're going to want to graph, so it would really help if we could build somewhat of an equation out of this, okay, so this is a direct variation because we have a 0-kilogram dog. The dog's not going to get any milliliters, okay? And we need to figure out what our independent and dependent variables are. So it turns out that the dog's weight, depending on the dog's weight, determines our milliliters, which means the weight of the dog is our independent, which then makes the dosage our dependent variable, which means this is our y-axis and this is our x-axis. Okay, this is historically what we use for each of those axes. The x goes on the independent, y on the dependent. Okay, which would mean we have to find a rate. So the equation we're going to try to use, because it's a direct variation, is y equals mx. Okay, and m is our rate. We're trying to figure out what the rate is, and because our independent is x, okay, we want our rate to be per kilogram. Okay, the per means 1. So we're looking for milliliters per kilogram. Okay, so because it's this slash here means per. Per is the idea of the number 1. Okay, so we're going to change our kilograms to a value of 1. Okay, and when we do that, we have to use a relationship that reduces our kilograms here. So in this case, we can divide by the number 12. Okay, and because we divided kilograms by 12, we're also going to divide our milliliters by 12. And when we divide by 12, that's going to give us this milliliter number, and this will be our rate. Okay, or in other words, our m value. So let's take our calculator out, and we'll take 30 divided by 12, and as you can see, I've already done this. It is 2.5. Okay, so for every 1 kilogram the dog weighs, when getting a dosage of medication, it needs to get 2.5 milliliters. So this is great. We can set up our equation very quickly. That means y, okay, this is our dependent, is equal to 2.5, that's our rate, per times our x, which is kilograms. So for every 1 kilogram, we get 2.5 milliliters of our medication. Okay. So now that we have that, we're going to put this into our graphing software. So you'll see I put the values in here, y equals 2.5x, and we're going to turn it on. Okay, so here's our line. This is a direct proportional relationship, right? Here's our 0 value. And we needed to know if the dog was 22 kilos. Well, since kilograms was our independent, that's our x-axis, what I'm going to do here is I'm going to put x is equal to 22. And that'll give me a vertical line. And where the vertical line intersects, okay, that's where our value is. So a 22 kilogram dog should get 55 milliliters of medication. Okay, I didn't have to put this in. I could have maybe on this software kind of scrolled my way up. 22, what do we got there? Yep, there it is. It's just a little harder to see. It's easier if I just draw an extra line and click it because of the way this software works. So 55. So what that means is if we have a, what do we say, 22 kilogram dog would get 55 milliliters of medication. Okay. If you'd like to see other ways to solve this question, just check out our other playlists on proportional reasoning.